Basically, the emissions get released through a stack up here. There's a small pipe connected to that stack which pumps stack emissions, which has got CO2, NOx, SOx, particulates, some heavy metals. It goes through a pipe, travels across here, and then down the side. You can see the pipe there. We'll follow it down, and then the pipe connects here, goes all the way across, and ends up getting connected into the side of Pond Biofuels pilot facility, which is right here. And this is where all the magic happens.
We have our smokestack emissions coming in through the large pipe, dividing into two to feed our two algae bioreactors. We have pond 1 and pond 2, and that's where the active growth of algae is accomplished using smokestack emissions as the feedstock for the carbon. The brains of the system is here, and this is what allows us to control the algae sort of accurately and understand what's going on. So for example, we get some data here. We know that there's 4,702 liters in pond 1 of active culture. We have 1,500 liters in our return pond, and our harvest tank has only 29 liters in it because we just completed a harvest cycle. This is what allows us to control the overall growth conditions of the algae and maintain the optimal growth characteristics, allowing us to, as I said, turn smokestack emissions into biomass. This is the guts of the system, the internals of the algae bioreactor, where we have an active culture of our photosynthetic organisms that are doing the carbon sequestration, actually turning carbon dioxide into value-rich biomass, which would include also the oil component of the biomass. The algae, after it's grown, it goes into the harvest tank, which is directly behind this tank, and comes to our separator where we dewater the algae. We essentially extract it from solution, and we discharge the algae below, and from the side over here we return the water, which ends up in this tank for complete recycling of the water. The only water that's actually used by the system is the water that's contained in the wet algal mass. So this is the algae as it comes out. There's a small amount of flocculant in here, which allowed us to separate a little more quickly today. We were doing this for the filming. We don't normally use the flocculant, but that's what the algae biomass looks like when it's at home. There's about 10 kilograms of algae here, which would represent about 20 kilograms of sequestered carbon. So we have the oil, which is essentially a triglyceride. This oil can be converted into biomass using a very simple reaction, and into biodiesel using a simple reaction, and that can be burned in your diesel car or truck. As a matter of fact, there are conversion kits available on eBay that you can burn this. They call this SVO, essentially straight vegetable oil.
Even up here, the more you get away from the kiln, it's supposed to get cooler.
Yeah, it's hot.
Like Steve was saying, even you saw that space just above the kiln.
Yeah.
Like the kiln and the roof.
Yeah.
Even you can put up like a belt there with algae, and you can dry it.
You could dry that. Yeah, that's amazing. Oh yeah, that's a good picture of the operation.
This pipe that you see down there,
Yeah.
that's what goes to our site.
Okay, so that pipe there.
Yeah. Like right now we're in the tower with the smokestack.
Yeah.
So it connects like 3 floors down, 3 or 4 floors down. It connects into their stack.
So the pipe goes there.
We draw the gas through that stainless steel pipe into the rubber pipe over there. And
Get down the side to there, and then all the way to the pilot facility.
Tony DiPietro. My background was automotive, worked in a metal stamping company as a lab supervisor, and change of career, I've ended up with Pond Biofuels, and I'm the site manager here.
I'm Jaime Gonzalez. I'm a mechanical engineer. I used to work in different industries in EPC, mostly resource, pulp and paper, forestry, oil and gas. Did some aerospace as well. Then I moved to Ontario to work in steel, and then with the downturn, I was looking for an alternative career and found Pond, and been with them 2 years now.
Well, immodestly, I'll say that we are the world's leader at this. There are, as far as I know, only 3 plants hooked up to smokestacks, and the other 2 are in open ponds. We're the only people with enclosed bioreactors using raw, untreated smokestack emissions. And this is a homegrown technology, so I'm actually very proud of that. In terms of conversion of positions or jobs or opportunities that are available in green industries, I see that as a real growth opportunity. Also because many of the established heavy industries support what we need to do here. Almost everything we have was custom fabricated, and it was custom fabricated using the same infrastructure that you would use for making bumpers. It's just used, instead of making bumpers, we're making tanks, we're making fittings or dewaterers. All this technology is not unrelated to what happens in traditional heavy industries, and it provides a massive opportunity if this can be deployed across the country or potentially across the world.
Well, St. Mary's Cement, if you consider the cement manufacturing process, we've got about 700 to 800 kilograms of CO2 being produced for every 1 ton of cement. So when you think of it from that perspective, our second most manufactured product becomes CO2. And that CO2 going out the smokestack is associated with climate change and greenhouse gases. We're taking a material that is being considered a pollutant. What that means now with Pond Biofuels is how can we take that and turn it into a product? And CO2, we know that, we've always known that photosynthesis requires CO2 to make oxygen and the building blocks of plant matter. So from that perspective, we got involved with Pond Biofuels as a way to take our second most manufactured product and turn it into a product of value and lessen our impact on the environment, improving our sustainability in cement manufacturing and in the improving the sustainability of all the products that we make, all the green infrastructure. When you consider things like a windmill having 870 cubic meters per 1 megawatt of output of concrete, that concrete and that windmill can be made more sustainably by using greener and greener building materials. This allows us to be that sustainable building material of the future, and if we can do it profitably at the same time, all the better. We're very confident that this can be done. We know that a cement plant is primarily a lot of duct work. All we have to do is take a smokestack and put it on its side and duct it into very large tanks, and we use the Pond Biofuels technology to essentially grow algae at a larger scale than this.
So in a way what you see here is just a modular, it's something that can be scaled up in a modular fashion.
Quite easily, and I think that this is that demonstration facility that is showing that.